This is Mr. Wright. Today we are going to go over the triangle inequality theorem. Right, so if you read what's on the screen, it says that if you add the two smaller sides of a triangle together, it has to be bigger than the third side. So whatever the two smaller sides, add that, it has to be bigger. It can't be equal, it has to be bigger than the third side. So let's just see what this looks like. So can these three numbers be the three sides of a triangle? So let's add the two smaller numbers together. 18 plus 19, that's 37. So then we ask ourselves, is that bigger than 40? So what's bigger, 37 or 40? 37 is less than 40, so it can't be a triangle. No, that doesn't work. Add the two smaller numbers, 33 and 37. 33 plus 37 equals, let's see, that is 70. Then we ask ourselves, is 70 bigger than 66? 70 is bigger than 66, so yes, that can be the three sides of a triangle. Here's another one. Three numbers. So you look for the two smaller numbers. 16 and 28 are the two smaller numbers, so I'm going to add those. 16 plus 28 is 44. Then we ask ourselves, is 44 bigger than 39? Yes, it is. So yes, that can be a triangle. That's how you figure out if three numbers can be a triangle or not. Next thing we want to look at is, let's say you have two numbers and you want to figure out, well, what does the third side of a triangle have to be given these two numbers? So there's two things you want to consider. You want to consider the minimum and the maximum. Okay, so let's say that like if x is the third side, like the biggest side, then x would have to be smaller than, if I add these two numbers together, I get 27. So x would have to be less than 27 because the two smaller numbers have to be bigger than the third side. Okay, so x cannot be 27 or higher. So x is less than 27. The other thing you want to consider is, what if the third side, x, was like the smallest side of the triangle? So if x was the smallest side of the triangle, that would mean that 16 would be the biggest side of the triangle. So if my two smaller sides were 11 and x, then if I add those two numbers together, 11 plus x, it has to be bigger than 16. So any number 11 plus 5 equals 16. So x would have to be a number bigger than 5. So x would have to be less than 27, but bigger than 5. So the way that you could figure that out is, all you have to do is add the two numbers that they give you together, 11 plus 16, you get 27. You subtract those two numbers, 11 minus 16 minus 11, you get 5. And then you just write your inequality just like that. So x is between greater than 5 and less than 27. So the x is always in the middle with those same two symbols. The lower number goes on the left, the bigger number goes on the right, and you just write your inequality. So let's just do an example of this. So if my two sides are 30 and 50, all we have to do is add those two numbers together, subtract those two numbers, and then 20 and 80, so x has to be between 20 and 80. So the way we write that is we set up the problem like this. 20 goes on the left, 80 goes on the right. So the way we read this, x is greater than 20 and less than 80. Here's one more example. You would do the same thing. Add those two numbers, subtract those two numbers. And the two numbers we would get would be, if I subtract them, I get 8. If I add them, I get 13. So x has to be, the third side of the triangle has to be between 8 and 13. So you do this whenever you're solving for that, when you don't have the third side. Okay. All right. The other thing we want to look at is, this is dealing with the side lengths and the angles of a triangle. So the biggest side of a triangle is always going to be across from the biggest angle. Let's look at some numbers. So biggest side is always across from the biggest angle. The smallest side of a triangle is always going to be across from the smallest angle. So there's always going to be that relationship. So even if you don't always have numbers, you should be able to use like the opposite thing to figure it out. Like if you have angles, you should be able to figure out like what sides are biggest and smallest. If you have sides, you should be able to figure out which angles are biggest and smallest. So let's look at a couple of examples. So if I want to know like what angle is the biggest in this first picture, I look at my three sides, and I notice 14 is the biggest number, so the angle across from the 14 would be angle E. Which angle is the smallest? 8 is my smallest number, so angle D is my smallest angle. So it's just the angle that's across from the biggest side or the smallest side. Next example, which angle is the biggest? So my biggest number is 39, so angle G is across from that. Which angle is the smallest? Across from 33 is H. So it works this way. It's also going to work the opposite way. So if you're given angles in a triangle, if you have an angle missing, that's going to be the first thing that you're going to want to find is figure out like what's that missing angle. So I would do 180 minus 83 minus 48. The missing angle in this triangle is 54. So this angle is 54. Now that we have all three angles, we look at the three numbers. The smallest angle is going to be across from the shortest side. So QR is my shortest side. The longest side is going to be across from the biggest angle. So 83 is the biggest number. That's my biggest angle. So PR is the longest side. Another example, we subtract these numbers from 180 to figure out that that missing side is 54. I'm sorry, the missing angle is 54. Now, which side is the shortest? So that's going to be across from the smallest angle, which is 54. So NP is my shortest side. What side's the longest? That's across from my biggest angle, 66. So OP is the longest side. So it's just going to be across from it. So that's how that works. So we have the triangle inequality theorem, and then we also had the theorems involving the shortest and longest sides of a triangle.